Okay, is this working? It looks like it's working. Okay, so this is going to be a long, rambling video showing OpenLander working on various different settings that it hasn't been trained on. I just downloaded a whole bunch of pictures from the internet, and it's as much for my entertainment as anybody else's, just to see how it performs on things that it hasn't seen before. So to explain a little bit, OpenLander is a segmentation network that's open source. I also have versions that are closed source that do a bunch more things, but the basic version is open source and always will be. And it allows you to classify ground level obstacles from a UAV. And it's pretty cool because it runs on a tiny little device, like the camera that I have rigged up pointing at my screen here. This is a tiny little camera from Luxonis that has a Myriad X Intel processor inside that actually runs a neural network. So the case is only this big, it's a tiny little thing. And inside it's minuscule, it's one of these boards. And the board is actually only 15 grams with the sensor. And it has a Myriad X TPU behind it. So you can put one of these in a drone. They're super cheap, super light, very small sensor. This one's $100. This little one here is actually the cheapest one they make, the Oak One Lite. This one's like the Oak One, I guess, $150. And that's all you need to run real-time neural networks on a drone, which allow you to do all kinds of automation, which I'm going to show some outputs of the neural network, and it's kind of up to you to figure out what you want to automate with it. The neural network is designed as a safety feature. It's supposed to detect ground level obstacles, and we're going to see how it performs on a variety of different pictures, which are not the same kind of environment it's trained on. It's trained on a kind of very suburban environment, Western European suburbs, and most of the people who are using it for drone delivery and eVTOL, like robotaxi type things, so short range, suburban, and none of it is actually commercially flying over like dense cities or anything like this, but we're going to try it on dense cities. We're also going to try it on like nature scenes and stuff, just a bunch of random pictures I downloaded of drone images like this, just to see how it generalizes. Google Wing just published some images, examples of how their system works a couple of days ago. And I thought it was kind of cool to see, like to actually have a visual representation of it, so I thought I'd do something similar. There's a couple of differences with the way that my system works. So first off, I'm not so much classifying objects as defaulting to negative. So everything that's not recognized by the neural network is considered an obstacle. So I'm actually training it to recognize safe areas rather than the other way around. And now the latest generation of OpenLander, which I just released a couple of days ago, now also classifies humans. So it outputs safe areas and it outputs humans. But it'll make a lot more sense if I actually run it, so we have something to look at. So let me start it up here. Should get some windows. Okay, here we go. So it's a really hacky setup because I actually wanted to run it on the device. So it's running on this camera. The neural network is deployed to this camera, so all you need to run this is one of these cameras hooked up to whatever's the brain of your drone over USB. So it's super light, but I actually wanted to show it running real time on the camera, so I'm not just cutting these pictures into small pieces and feeding them to the neural network on a big GPU or something, so you can actually see the performance. So it's running at 15 frames per second on this tiny little camera. I have other versions which are for like more commercial purposes, which also include some other cameras like stereo systems like this. This is actually a kind of small one. There are much bigger ones which have a wider base length to do stereoscopy on a much longer distance. These are all from Luxonis, and Luxonis makes fantastic devices. You should try it. And this is a Power over Ethernet one. This one's kind of cool because it has a Raspberry Pi inside. So this is actually the entire brain of a drone. This thing does all of the sensing. So you have stereo with these two sensors. You have RGB with this sensor. And so I can run real-time segmentation neural networks on the RGB image. And I can run real-time stereoscopy on these two, which allows me to detect a whole bunch more obstacles and different kind of stuff. I'll do another video with one of these pretty soon. But so here we're just looking at the neural network output. So this window over here is the output of the neural network overlaid over the image that the camera is seeing. And I've made a couple of other bits here. This one is just showing the mask. So it's actually two masks because this neural network is supposed to be showing in blue where it's safe to land. It's not really trained for this altitude. It's meant to be lower down because it's for kind of when you're getting close to the ground. But so blue is safe landing or non-obstacle, and yellow is supposed to be humans, but it's super sensitive on the humans because it really needs to avoid humans. That's kind of the basis of the network. And at this altitude, it's getting really confused with especially like a really dense urban scene like this that it hasn't seen before. So there's a lot of yellow, which is obviously wrong, but it's also being quite safe looking at this. So this image down here is the aggregate of the masks. So it's combining both classes, which doesn't make a lot of sense or anything, but just kind of to get a look at what's going on. That's a bit clearer than this image sometimes. And the top left here is like a selected landing spot, which is just showing what happens applying some logic to this. So all it's really doing here is selecting the largest outline from this, and filling in holes, and then there's a filter on the size. So if it's more than a certain number of pixels, it'll consider that that's like a safe dropping spot, because that was the example I coded in here at one point. It doesn't make a whole lot of sense. It's just to show that you can use the neural network to build your own logic on top of it, and you can do whatever you want. So this might make sense for some use case, but probably not so much. We'll take a look at some pictures and see if it would ever be usable like this. So the first picture we have here, there's a bunch of different stuff. Logo, there you go, it's my company. So I just downloaded lots and lots of different things from Unsplash. All kinds of different things the neural network has never seen, so we're just going to kind of go through them and take some time and figure out how it looks. So as I said, the neural network's been trained on suburbs, like Western European kind of suburbs, because that's where my customers for now are using it. But it's generalizing quite well because it's trained on a lot of data. So I have my own process to make synthetic data from real-world data. And this is trained on about 6 terabytes of data. So it's a tiny little neural network because it fits on this little mirrored processor here. And I have versions which are larger resolution input and larger networks and things like this, but they don't run in real time on this device. They would actually maybe run at like 2 or 3 frames per second, but the goal here is really to show OpenLander, which is the fully free and open source version, which is the smallest neural network and runs in real time on this device. And we're going to see what the performance of this one is. So let's zoom into this image and kind of pan around as if we were a drone. So obviously the camera's not focusing very well on the screen, so that's one penalty to the system. But hopefully we can still figure some things out and see what happens. So you can see the mouse is in the picture. I'll try and keep it out. So it's doing a pretty good job here with this warehouse scene, which once again it's not trained on, of figuring out where the buildings are. So the buildings are not segmented, meaning they're an obstacle because it's default negative. All of the blue stuff here is safe delivery, so that looks pretty good. And then we have some things that the neural network considers above the threshold that it considers to be humans. They're not humans, probably. I mean, we could maybe zoom in and see. There might be some humans there. Once again, the mouse is in the way. I don't think there really are any. But it's seeing stuff as humans, which is kind of being too sensitive on that aspect. For now, with this very small neural network, I prefer to keep it very, very sensitive. I prefer that it thinks that occasionally there's a human there, and we avoid it than missing a human. It's the whole point is for safety. So we can pan around in here. You can see the neural network does a really good job with cars. It's seen a lot of cars, so it's really doing a good job detecting that. Let's go to somewhere where it's pretty stable, like this. As you can see, the quality of the picture really degrades when I zoom in, so it starts to get very hesitant, the neural network. But I can explain a little bit what's going on using this part here with the top left image. So here, the logic that's built into this, once again, not something you'd actually want to use in deployment, is considering that this area is big enough, probably, I think I'm aggregating over a few frames, so it's big enough over a long enough period that we consider we can drop there. And it's just putting this drop circle in the middle of that area, which, yeah, you'll see in other examples doesn't always make sense, but it's just to show that you can build your own logic on top of the output of the neural network. And there's all kinds of different ways you can do that to make sense for your particular use case. And in real-world deployments, ideally, you're combining it, if you're building this as like a commercial system, as the brain of a full delivery system, for example, you'd want to use stereoscopy as well, which is what Google Wing are using. So Google Wing have a funny, interesting setup where it looks like they're using 2 pairs of stereo cameras, I guess 2 for redundancy. They didn't explain that completely, but they're only using stereo pairs, it seems. So there's only mono, black and white images. So I'm using RGB as well because I'm training the neural network for segmentation on RGB, because there's a whole lot more information there that we can use to understand what's going on in the scene. So we're going to go over a bunch of images, and I'll ramble a lot, and we'll just try to figure out what's detected and what isn't. It would be cool if there were some humans in here. I'm not sure there are. The buildings, see, with the flat roofs, it gets a little confused by this sometimes, because it has seen some in these suburban environments, but not so many. Still doing a good job on the cars. Oh, look, there's some humans down here, and it's cool. They're actually in the right category. They're in the yellow category. So we've detected the first humans, which are well recognized. It's being overly sensitive around this category, so you can see there's a lamppost there that's being categorized as a human, but that's fine. I prefer it to be like this on this version of the neural network. We have some train tracks, have the mouse in the image again. Yeah, that's about it for this one. If I zoom out, it starts to break down because it's not trained on that resolution, but still, it knows where the buildings are. Like if it was to drop out of the sky right now, you could kind of optimize it to try to drop in that blue zone at the bottom. So let's take a look at some more pictures. I have loads and loads of them here. We won't go through everything, but there we go. It's a pretty one. And so these pictures that I took from Unsplash, they're all kind of editorialized. So it's stock imagery. And so people are super saturating the colors. They're often taken at sunset, so they look really cool. So they look really pretty. It's not something you'd really run into that much in a real world setting, but it's cool. It's interesting to see because actually this presents even more of a difficulty to the neural network, because the training data set has all kinds of augmentations that simulate extra contrast and this kind of thing, but that's not the main bulk of the data set. So we're kind of already adding some difficulty here, and we can see how it performs. It's still doing quite well is kind of the point of this. But you'll see it does an okay job. So let's zoom in a bit. This is kind of the height where you'd actually be cruising with a commercial drone. And you can see it does a really, really good job, actually, of separating out the buildings, all the rest of this stuff. Like you have some trees here, and the people here. There's it looks like someone with a bike or cart of some sort, which is correctly categorized as a human. There's a guy here standing, looking at his phone, who's correctly categorized as a human. So I guess I should credit this. This picture is from Shuttersnap on Unsplash. So thank you very much for that. Unsplash is great. Lots of free stock photography, lots of aerial views like this. I don't use it for training, but it's cool to see, and it's cool that people are sharing this. So I don't know where this is. I think it might have been Indonesia. I think there were a few from Indonesia, but there's none of this in the training data set. But you can see it generalizes quite well. So if we were to deliver here, or if we were to land here with a drone, it's correctly figuring out that the safe landing spots are the streets here, the blue part, and not the tops of the buildings. We can pan across and we can kind of see if we can get it to fail if we stare too closely at the building, but I guess not. This type of building is pretty well learned by the neural network. This is interesting here. You can see the courtyard up there is being considered as a safe-ish for landing when you're high up. It's kind of recognizing that's a ground level area, which is interesting. But if we zoom in further, we might be able to get it. Yep, there you go. The courtyard is safe. That's actually quite impressive. I hadn't tried this before. And the road is safe, and the bit in between is correctly recognized as a building. So, pretty picture. Thanks, Shuttersnap. Let's take a look at the next one. Shuttersnap again. This is a really, really cool and interesting picture. So I guess all these buildings are identical. I need to zoom in, otherwise the app switches picture. Let me see, there we go. So that's zooming. These buildings are kind of cool looking. I guess they're all identical. It's kind of blown out, so I think the neural network is going to get confused by that. In the real world, it would auto balance to the exposure of the scene. It seems to be doing an okay job rejecting the buildings as unsafe, and it seems to be doing a pretty good job actually with the courtyards back here, which I'm surprised about because these are very specific. Like there's probably nothing that looks close to this in the training data, but it's doing a good job. So avoiding the trees, lots and lots of trees in the training data. It thinks there's a human in that little backyard here, which there might be. I wouldn't be so certain, but it could be. Rejecting the buildings. This is actually surprisingly good. I thought it would probably fail on this scene. If I zoom out, it will probably begin to fail on these buildings at some point. Or maybe not. There we go. Now we're super high up. Like this is not where you would actually be using this neural network for delivery. It's not trained for this kind of height. I'll probably train one for this height later, but not yet. If we go far out enough, you can see that piece on the right there. It thinks that's a street, and that's actually the top of these all identical buildings. Still cool to see. Good picture. Thanks, Shuttersnap, once again. Another Shuttersnap. I guess these are all alphabetically sorted, so yeah, so all the same guy for now. Don't know where this is. Let's zoom in and have a look. What can we see here? It's a construction site. Oh, there's some garden. So the building is being ignored as unsafe, which is cool, which is expected, but it's doing a good job. The street is safe for delivery. The cars are being avoided. It thinks there's a human there, but that's actually a cone. Oh, there's a human. That's actually a human. I didn't see that guy. The neural network found it. And here we have a construction site, which should be interesting. We should get some failure there. So I guess this is sort of ground level. Once we get really in the construction site, it's kind of confused. This is really messy. It is detecting the people, which is kind of the most important thing. There's two people here, so we could safely avoid those if the drone was going to crash to the ground. But the rest of the construction site doesn't really know what's going on. It has been trained with a bunch of construction sites, but each one is so different that even with a lot of training data, I wouldn't expect it to understand that semantically so well. So here's some garden. It does a surprisingly good job spotting small areas of garden. Like if I zoom out here, this is really stable. So even if I was very, very high up and I was coming down with the drone and I was looking for the best place, as I come down, I'm keeping this part of garden here on the right as the best delivery spot. Now let's see if I zoom all the way in. And here we have it as a nice clean area in the mask there. So then I could center that and bring my drone down, and now it's ready to drop. So the basic logic that's in that image, it's just OpenCV filters. This is telling it that it's big enough as a drop area. So we could kind of hover here with a drone and drop a package, or we could land there if it's a bigger UAV of some sort, not an eVTOL. It's too small of a garden. Don't park your helicopter there. So there you go. Let's look for some other pictures. This is the same place again. I guess it's alphabetical. Bunch of cars. We've seen it does cars well, so let's look for something else. Now this is cool. This is Cody Fitzgerald. Thank you, Cody. So let's zoom into this. This is kind of more suburban area. You can see it's segmenting the trees out correctly. There's a pile of leaves there. I'm quite happy with that. It's considering that those are an obstacle, but it's also not going crazy with all of the brown leaves, which is good, because it's actually been trained specifically for this, for autumn. So in the training data, I was careful to have a lot of autumn conditions, so we have lots of leaves on the ground. So we're still very high here. We should go down a bit like we're attempting a delivery. So these cars are completely blown out. I'm not sure whether you can see that. They're completely white. It's having a harder time with that. The contrast is failing on this car. In the real world, you probably wouldn't get those conditions because the camera would adjust. But it's still doing a good enough job on the white one here. I'm quite happy with that, actually. It does a pretty good job there. Trees are segmented out quite nicely. It's an interesting building because in the training data set we don't have any buildings that look like this with this kind of corrugated roof. And we're still doing a really good job at segmenting out. Some of these pictures are kind of low resolution, like this kind of degrades too much. The neural network's still doing okay, but like this is not very good, and I wouldn't really expect it to be good because I should stick to higher resolution images. So once again, we're really doing a pretty good job with this thing of keeping small areas of garden as being like usable. That little piece there is pretty good. Let's zoom out and see if there's anything else interesting in here. Oh, there's some tennis courts. I don't know what we'll do with tennis courts. That's interesting. Here we go. Oh, it's not a tennis court, it's a playground. So all of the playground equipment is being identified as obstacles, and strangely enough, part of it is being identified as humans. But that's okay, I can live with that, as long as that's pretty safe. The rest of this is roads and trees and stuff, nothing exceptional there. Oh, there is a tennis court, it's over there. And it's blue, that'll be interesting. Oh, blue tennis courts. Neural network does not like that. Not safe for delivery. Yeah, so I mean, guess what? It hasn't seen... Oh, it's a basketball court. It hasn't seen blue basketball courts in the training data set. So it's kind of flipping back and forth. It's not very happy about this. Sometimes safe, sometimes not safe. Yeah, I wouldn't recommend you try to land on a blue basketball court based on this neural network. But yeah, everything else is working okay. Alright, let's switch to the next picture. I'll do just a few more pictures and then that's enough of this intro video. Oh wow, this is an interesting one. So from Denis Rodyonenko, thank you very much. I have no idea how this is going to perform. So we have roads, we have railways. Oh, I've trained it on railways, so it knows to avoid railways. You don't want your drone landing on a railway. It's also trained with like wires as an obstacle, and I'm probably going to extract wires as a separate category in the future, like humans. The reason being that wires tend to be higher up, and if you're relying on just the RGB to navigate, it's cool to be able to fly high up and see where the wires are and make sure you avoid those as the first kind of line of vertical obstacles. So yeah, it's doing a good job here of calling all of this unsafe. It's flipping back and forth though. Once it sees other obstacles, it's kind of flipping out. This one is also particularly low resolution though, so some of this is probably not very good. There's a human down there. It's finding the human. I think all of these cobblestones are too low res to really do anything with. I should probably try to find a similar one to this in higher resolution. So once again, roads are safe, cars are not. Does an okay job with this, but I should probably just switch to something that's higher res. Still, I'm curious to see. Does a good job there, avoiding the hedge. Yeah, so kind of inconclusive on that one. That's a really messy scene. Yeah, once I zoom out and there's less detail and it's the resolution, the low res of the image doesn't matter so much, you can see that it's doing an okay job of segmenting out cars and things like this. So, next image. Here we go. Oh, this one's super ridiculously high contrast. It's a cool image. It's very pretty. By Deva Darshan. Thank you very much, Deva. But this is not a scene you'd encounter in the real world with your sensor, because nothing's ever going to be this high contrast. I was just curious to look at it. Some of these pictures I just downloaded because they look cool, so I won't spend much time on them because it's not what we're here to see. Playground, once again. I'm really happy with the way the neural network handles shadows. There's a lot of work been put into this to create synthetic data with shadows so that the neural network doesn't get confused by them. So you can see there's a really, really hard line of shadows in the trees up there. and it's not influencing the perception of the neural network very much. So it's considering all of this to be safe landing, except all of the pieces of the playground, which is considering to be human category, which is once again fine. Human is a category of obstacle, so as long as it puts that in obstacle, it's doing a pretty good job. Once we zoom in, it's probably going to change a little bit, yeah. So now we can see the shape of this, and it's actually considered an obstacle. But as you can see, like that transition with the shadow, I'm really, really happy with that. I hadn't tried these pictures before, but it's doing a really, really good job there. There aren't really many obstacles in this picture, so there's not that much to see. Yeah, playground stuff. Can't land there, can't deliver there, so that's fine. Oh wow, so this is going to be interesting. So this is a seaside. Neural network's never seen a seaside. Actually it kind of has, but not this kind of seaside. So let's zoom in and see what's going on. So all of the parasols and the little huts and that are considered obstacles. It has seen sand, and the dirty sand is considered safe, which is fine. It's even categorizing some sunbathing humans there. Not bad. Thanks, Eduardo Drapier, for those pictures. Not sure you're allowed to take these pictures, but I hope you got a model release for all of these people. There you go. Oh, it's doing pretty good. If I zoom in a bit more, we can probably see some more of like how these are being categorized as obstacles. Or not. Like some of these are not, which they should be. So the big parasols there should be probably categorized as humans. So I need to put some more of that in the training data probably. But there you go. This is a kind of weird image in terms of color, because it seems to be the output is like the white channel is locked. It's only going to like 240 instead of 255, which is creating kind of a confusing look, at least on my screen. But it's working okay. The neural network's doing okay. It's finding some people, avoiding some cars, all of this kind of stuff. Yeah, I should probably train some more on this kind of data. If I zoom all the way out, it's considering all of the human-y stuff to be humans, which is interesting. That's not on purpose. That's definitely kind of byproduct. All right, let's have a look at another one. I won't do this one because it has ridiculous unsharp mask on the image, so it's really pixel mush when you zoom in. It does kind of okay, but like you're never going to get a sensor that actually does this output in real life. So yeah, it's a cool picture. Downloaded it for that, but that doesn't really make sense. Lots of cars, more cars. I think we've done cars at this point. This is kind of a cool scene. I wonder what happens here. I'm not sure the resolution is enough, but it's not trained on water. So it's considering water to be unsafe, which is fantastic. That's what I would want it to do. And I'm curious about the pontoons over here once we go over these. It's doing an okay job. If you wanted to use it here, you'd probably want more local data. But we're avoiding most of these buildings. Classifying that kind of okay, actually. I'm surprised. I thought it would fail worse here. It's actually not bad. It's not doing a very good job with those rocks, but those are kind of low res once again. The road is okay. We're avoiding the buildings. Doesn't like boats, which is great. And it's finding some humans. Wow, that's really too low resolution once we go in there. That's just some squares. That's cool. I'm surprised, actually. I thought it would do much worse there. More beach. Cool picture, but we've done one of those already. What's this? So this looks kind of like Italy or something like this, like a built-up coastline. So we've never seen anything like this in the training data. Roads are safe. It's the top of that building it's considering safe, which is kind of cool and interesting because this is obviously like a kind of courtyard. There's some deck chairs and stuff there. And the neural network is considering that one safe, which it kind of would be. Like it's probably not a bad place to land or deliver in the sense that it's actually flat and a used surface versus the roof next to it. And the roof next to it is being considered unsafe, and that one is being considered safe, which is interesting. It's an interesting emergent behavior, because it hasn't been trained to do that, but that actually makes quite a lot of sense. So that's a good one. All right, let's scroll around, see what else is in this. That square is nice. It's considered safe, which is great. It's interesting geometry. I'm surprised that that works, because it's a very specific pattern of triangles. I've never seen that before. So roads are safe. There's a human. Cars are unsafe. Yeah, it does a pretty good job, all things considered. So it hasn't been trained on anything that looks kind of like this Mediterranean scene. Nothing like this. This is pretty straightforward. This looks kind of like Germany. We have these buildings with the wooden beams across the front. I guess Germany or Eastern France, something like this, or further east. Yeah, I mean, this is pretty straightforward stuff. It does a good job here. The cars are being avoided. Some humans are being detected. There's people on bikes. So the human category, it's actually been trained with people on bikes, people in wheelchairs, people with like various different implements, including parasols and things like this. Like I tried to make it pretty wide. It's trying to be as inclusive of all kinds of different people as possible, like all kinds of different colors and geometry and stuff, which is also probably why it's being very permissive with that category, and it tends to pick up too much stuff in the human category. But I prefer it to be that way than the other way around, so I'm leaving it like this in the data set. So it does a pretty good job on that. But there's nothing really difficult here. It's nice to see it do a good job, even when it's not difficult. That's also part of the point. So here we have a swimming pool, which is interesting. There were a couple in the training data, but not many. And it seems to consider the entire pool to be safe landing, which is definitely not great. I wouldn't want to use it that way. You might want to put in place some extra protections for avoiding pools. Once you get close enough, like here, it seems to understand that the pool is something weird that's not seen before. So some of this could also be the specific contrast and the way the colors are adjusted in this image that's causing it to break down with the pool there. It's avoiding everything else pretty well. It's tables and these deck chairs and everything. Let me zoom out a bit more. Once I zoom out, it just goes crazy on the pool. I guess the pool looks close enough to like a color-shifted road or something like this that it's very, very difficult for such a small neural network to differentiate. There's very, very few layers. You can see it's doing a good job on the trees. It's found a little safe spot in between the trees and the barrier there. That's an interesting one to see. I'm not surprised the pool doesn't work, but there you go. It's confirmed. So I don't know what this is. It looks like a battle zone. Yeah, thank you, Humphrey Maliba, for that picture, and Hendrik Morkel for the previous one, and the two previous ones, and Janis Gutsamanis. There we go. Get the credits in. So this is from Ivan Bandura. I don't know where this is, but it looks like a battle zone. It's also very, very strong contrast. No, actually, it's very low contrast. Everything is kind of grey in this image. Doing a good job of recognizing trucks. A lot of those small grey details are getting lumped into the human category, but that's probably okay. Like insofar as if you wanted to deliver here, it wouldn't really matter if you avoided those spots. It's probably best to avoid them than to drop on something that's potentially a heap of garbage. Yeah, it's not a particularly interesting image. Kind of cool looking, but does an okay job there. Let's look at something else. Same guy. Yeah, more backyards. Nothing extraordinary there. This one just kind of looks cool, but it's a very, very strange lighting. The sun's really, really low. So it's not something you'd encounter in real life. It's also very noisy. Neural network's been trained with loads and loads of noise and that kind of augmentations, and as you can see, it does fine. It's even found. So this goes into the human category because there's a human there on a scooter, and people on lightweight vehicles I've put directly in the human category, which gives you, yeah, it's just more safety. Like you don't want to drop directly on someone that's on a scooter. And yeah, it's doing a good job there, avoiding buildings and stuff. This is quite cool because it's very, very bad lighting and quite noisy. Alright, should probably end this because no one's going to be watching for 45 minutes or however long this has been, 35 minutes. Let's just see if there's anything else cool here that's kind of extraordinary. Oh, here's a beach, very pretty beach with palm trees. So if we zoom all the way out, that forest is obviously a no-go zone, which is great. The neural network's finding that very well. And what do we have if we zoom in? It's not doing a good job on the sand there. It's also, this one also has kind of a clipped channel. It doesn't like that color of sand, so none of this is deliverable. It's probably fine. You probably wouldn't want to deliver there. And the neural network has just never seen anything like this before. Once we get in between the buildings here, it's finding humans, that's fine in this setting, but it doesn't want to land anywhere here, which is probably okay. Alright, cool picture. Thank you, Justin Kaufman. This looks kind of like Middle East or Southern Europe. It hasn't been trained on any of this. We can zoom in and see what happens. Oh wow, no, this is actually very low resolution, this one. So it's kind of going crazy on the flagstones there. I guess it's too much texture and it's not used to seeing that. We're avoiding the cars okay, the buildings are kind of okay, but at this resolution it's kind of mushy. Detecting some humans there. It's okay, it's not perfect by a long shot. So there you go. I need more pictures. Send me your pictures and 3D models of Southern Europe and things like that. It's probably okay in real life. Also, this is super low resolution. It'll definitely do better on an actual drone. But there you go. I think that's the last one in the folder. Is it? Oh no, that's just a cool picture. So what else have we got? Here's some forest and some buildings. Nothing super exceptional. It likes the courtyard. Need to zoom in some more. There's some people down there. We can avoid the people, deliver over here. Yeah, this is kind of pretty basic. This is the kind of stuff it's been trained on, so it's probably not many failures there. I guess part of that roof, but that's also underexposed because we're pointing the camera at the screen. Yeah, so nothing particularly exciting going on in this one. Let's see what else. Just a pretty picture. This is really crazy saturation. This is obviously someone pushing the green and the red just to make a cool looking image, but it's best not. I won't play with that with the neural network because you'll never actually get those conditions in the real world. Another beach. Yeah, once we get close, it doesn't like the beach. It does a really good job of spotting people here, actually. That's kind of interesting to see. All of these little clusters on the beach. A lot of those do actually look like they're people. So it's kind of an idea that you can also use this neural network for search and rescue. The idea being that if you can automate a fleet of drones that are doing this, you can kind of evaluate a density of people in an area. If you have drones cruising back and forth and you're logging the number of pixels that correspond to the human glass, something like this. That's another thing that you can do with this. I'm actually building another neural network for that specific purpose, but you can already kind of do it with this. It's just a cool picture. This is interesting because you've got all kinds of construction material here. I'm curious to see what the neural network does with this. So it's doing an okay job with some of it. It has seen some of this kind of thing in the training data. I have some industrial areas like this. It's not bad. It's kind of falling apart. There's something weird with the colors. It goes crazy on the left of the image when there's this kind of color shift. See here, it just breaks apart. Doesn't really know what's going on until we have some more content in the image. That's not a behavior you see in the real world. This is definitely due to the camera pointing at the screen. It's okay. It's doing an okay job of rejecting all of this construction material stuff. Not too bad. Well, that's pretty good. All right, one more and that's it. One more. This is a parking garage, but it's ridiculous colors. It's completely yellow, so let's not focus on this. Yeah, this is like a Norwegian hut on a lake, which, yeah, kind of exceptional. This is another beach, a city. Let's have a look at this. This can be our last image. It's interesting because it's super, super high contrast. So obviously this is like editorialized to look cool. And it does look cool. It's a very pretty picture. Thank you, Nick Stevenson. But it's another cool example where you can see that the neural network is not getting fooled too much by that difference in contrast here. Until you get really close and that's all that's in the image. But it's correctly categorizing this as a human and this whole area as being safe to deliver because it's the road. So that's pretty good. That motorbike here is considered a human. Once again, like I put motorbikes basically in the human category because you never know if there's going to be someone on it. Yeah, it's interesting. It's a cool one to end on because of the high contrast, so it's a very difficult use case. And we've got a human here, well detected, slightly balding. Sorry, buddy, that's bad luck. Another human over here. The camera's not looking that far over, is it? And the buildings are being rejected pretty well, it seems. This is actually, it seems like very, very wide. This is actually shot with a much wider camera than what's part of the training set. But it doesn't really matter that much. Like this kind of surface is still being detected as basically building surface and being rejected. It goes crazy when I put the mouse in the middle of that. It's just detecting the mouse. But other than that, it's doing a real good job. So there you go. This has been a rambling, long exploration of OpenLander, where it is now, the things that you can do, and the super cool things that you can do with a tiny, tiny little chip like this. Once again, this is all you need. This is like $100 from Luxonis. Stick this on your drone and you have this level of AI capability. It's completely free. You can download it and do whatever you want with it. It's there's no license. You can use it for commercial use. That's absolutely fine. It's set up that way. And all you need is one of these and you're ready to go. It's all explained in the repository. And if you want extra capabilities, if you want to detect extra things, if you want to use a version with the full stereo system or even the wider stereo system, I make those as well and you can buy those separately. But with this, you're already good to go. There's loads of cool stuff you can do. You can add this as a security feature to an existing drone where you can build a whole system around it. And it's free, so why not? Off you go. Thanks for watching. Bye-bye.